In this circuit, we find a very large capacitor. In fact, it's 310 farads. As you can see here, 310 farads at 2.7 volts DC. We are asked to calculate the voltage on the capacitor at a specific time. In this case, what is the voltage on the capacitor at 60 seconds? We are given a DC power supply of 2.5 volts, and we know that the switch closes at time equals 0, and we have a 1/2 ohm resistance in this particular circuit. Before we start, it's helpful to review our note cards. Here we have an RC transient circuit where the capacitor is initially uncharged. What will happen is that as time progresses, as soon as the switch is closed, we have this curve where the capacitor will eventually charge up to the source voltage, which is listed here as Vs. The equation for the circuit is voltage on the capacitor is a function of time is equal to the source voltage multiplied by 1 minus e to the negative t over tau, where tau in this case is the product of R and C. To get us started, we first calculate tau. In this case, tau is equal to the product of R and C, which is equal to 1/2 multiplied by 310. So RC is equal to 155 seconds. Once we have tau, we can then calculate the voltage on the capacitor. So VC at 60 seconds is equal to the source voltage, in this case 2.5, multiplied by 1 minus e to the negative t, in this case t is 60 seconds, over tau, which is 155. We can solve this using our calculator. 2.5 multiplied by 1 minus e to the negative 60 divided by 155. Close and close is equal to 0.8 volts. So the voltage in the capacitor at 1 minute is equal to 800 millivolts. Now that's a long time, and you might say, well, how long would it take to charge this capacitor all the way up to 2.5 volts? And the answer to that is it would take about 5 tau. In this case, that's 5 times 155, which is about 775 seconds. If you divide that by 60, that comes out to about 13 minutes.